So in this video, we're going to graphically determine a limit for a piecewise defined function. So here we have the function f of x equals 1 as long as x isn't equal to 3, and f of x equals 0 when x is equal to 3. So the first step is graph the function, which I've already done, but in the homework you'll probably need in general to graph things yourself. So first step is graph the function, which I've done. And then we want to do the same thing that we did in the previous video. We want to look at the number for which we're interested in the limit. In this case, we want the limit as x goes to 3, and we want to create two open intervals centered at 3. In this case, when we look up here, we see that the piecewise defined function is defined for all x. So we know that the domain of this particular function is x is an element of the interval from negative infinity to infinity. So if we're looking for the limit as x goes to 3, we'll make the intervals negative infinity to 3, and then we want an open interval, so we won't include the 3 in the interval itself. Union, and then we'll go from 3 to positive infinity. So there's our two open intervals. And just like we did before, we want to let our x values approach 3 first from the left interval. So we're going to let the x values approach 3 from within this interval. So we're going to approach on the x-axis an input of 3. So we're going to take the limit as x goes to 3 from the left-hand interval. So we say 3 negative. Take the limit as x goes to 3 from the negative side of our function. And then we notice that as the inputs approach an input of 3, we're moving along the graph like this towards this hole right here, because f of 3, when you plug in 3, you do not get 1, you get 0. So the ordered pair input 3, output 0 is on the graph. So as we approach this, we see that the outputs are approaching the constant 1. So the limit as x approaches 3 from the negative side just equals 1, which makes sense because up here it looks like the function is just a constant. And now we want to approach the 3 from the right-hand open interval. So we approach 3 from this direction, so we take the limit as x approaches 3 from the positive side of f of x. And as we move towards an input of 3, we're moving along the graph towards this hole right here. But it looks like, well, the outputs still look like they're 1. We're not really approaching from above or below because the function's constant. So it looks like the output is trying to give us a 1. It looks like the ordered pair 3, 1 is trying to be on the graph of the function. And then once we've found the two one-sided limits, the left-sided limit and the right-sided limit, we can draw a conclusion. We have to ask the question, are they the same? And they are. They're both equal to 1. And is the 1, the limit, a real number? It is, which means the limit exists. So now we can draw a conclusion. We can say because the limit as x goes to 3 from the negative side of f of x, and in the homework you would be expected to do this to get credit, equals the limit as x goes to 3 from the positive side of f of x. So we identify that the two one-sided limits are the same and that they're equal to the real number 1. So because the two one-sided limits are both the same and equal to a real number, the limit exists. The limit as x goes to 3 of the function f of x is just equal to 1.